Unit 5, Lesson 7, the present value of an annuity. So we did present value of compound interest, which meant we found out how much money we needed now to get a certain amount in the future. Present value of an annuity is similar. It's the amount of money that must be deposited now to provide a series of payments in the future. So for example, suppose your grandparents want to give you $250 each year for the next 10 years, starting a year from now. The present value of this annuity is the amount of money they will need to put in the bank today to cover that payment of $250 each year for the next 10 years. To calculate the present value, we use this formula. So another complicated formula. The trick is being familiar with your calculator and knowing how to use it. So present value, R, I, and N all mean the same thing. Note, just like with compound interest, the exponent is negative. So let's look at a couple of examples. Uh-oh, why won't my page go forward? There we go. So we're going to do our present value. R N over I. So what amount of money is needed to provide an annuity of $5,000 semi-annually for the next 5 years if interest is 3.5% compounded semi-annually? So we are getting a regular amount of $5,000. Our interest rate is 0.035. It's compounded semi-annually, so divide by 2. And we're talking 5 years compounded semi-annually. For 5 times 2 would be negative 10. Divided by my interest rate, 0.035 divided by 2. So to get your calculator to work correctly, you want to put brackets around your whole numerator, divide, brackets around your denominator, equals. So take a few minutes. We'll see if we can get the right. So after playing with that for a few minutes, I got $45,506.11 in order to get $5,000 twice a year for the next 5 years. Let's try another one. Cash for Life is a lottery prize that's $1,000 a week for 25 years. If interest can be earned at 5% compounded weekly, what is the present value of this prize? So our present value is your regular payment, so $1,000 a week. 1 minus 1 plus our interest rate, 0.05. Weekly, there are 52 weeks in a year. 0.05 divided by 52. My exponent, 25 years times 52 weeks in a year would mean my exponent would be 25 times 52, 1,300. So negative 1,300. All of that divided by the interest rate, 0.05 divided by 52. Okay. So I'm going to pause for a minute and do my calculation, you too, and we'll see if we get the same answer. So we would have a present value of $741,856 roughly for $1,000 a week for 25 years. Last one. In order to have money during retirement, most people create a retirement savings fund to retire comfortably. Today, about $2,500 per month in income is required. If interest is 4% compounded monthly and the retirement fund is to last 30 years, what amount of money should be in the fund for a person who is going to retire today? So we have our present value. Our regular payment will be $2,500. 1 minus 1 plus my interest rate, 0.04, compounded monthly, so divide by 12, and we have got 30 years times 12 months a year would be 360, so negative 360, all divided by the interest rate. So remember when you're entering it in your calculator to make sure you put brackets around your numerator, divided by brackets around your denominator, and then you can hit equals. So So the value today should be $523,653 and about 10 cents to earn $2,500 a month for 30 years. So again, that leaves you with some questions to practice. Make sure you're getting to understand how your calculator works.